So just like we did with our tables, we're going to check out, do we have growth or decay from an equation this time? And we'll go through those steps on what we're going to look at, what we consider. We're going to answer the question. We're going to answer 3 questions for all these. Does this represent growth or decay? What is the initial value? And what is the percent increase or decrease? So as we go through each of these questions, I'll kind of highlight stuff that goes along. So like, is it growth or decay? Whether being growth or decay does not, the 100 does not matter. So this number is our initial value. So this one's really easy. Our initial value is 100. It's always that A value. For our growth or decay, we're looking at what the base of our exponential is. So 0.96, does that represent growth or decay? We assess, is that number greater than 1, or is it between 0 and 1? 0.96 is between 0 and 1, so that represents decay. And we'll write that note. So that is decay. And that's the reason why. When we look at percent increase or decrease, we're really just taking our growth or decay factor, the 0.96. And remember, for decay, it was 1 minus r. So we want to know how much smaller is 0.96 than 1. So I can go 1 minus 0.96. That will give me what this r value is. That's what the percent increase or decrease is looking for, is that r value. And if I subtract those two, I get 0.04. Now, it says here percent. We want to write that as a percent. That's in the decimal form. So to get that percent, now taking a decimal, if we remember, percent to decimal, we moved to the left. Now we need to move to the right. Our percent increase or decrease, here it's decrease, would be 4%. And that would answer all 3 things. As we look at the letter B, does this show growth or decay? I'm looking here. Is that bigger than 1 or smaller than 1? That is bigger than 1, so this is showing growth. My initial value, I don't see a number out here. But there's always that invisible 1 that can be multiplied there. So our initial value would be 1. And the last part, percent increase, decrease, remember, we said this is growth. We're looking for r. So that means we added a number to 1. So if I want to know how much bigger this is than 1, I can go ahead and subtract 1.1 minus 1. That gives me 0.1. If I make this decimal into a percent, I move to the right 2 spots and fill in a 0. I am increasing by 10%. Same type of question. Growth or decay, I look at my base. That is smaller than 1, so we have decay. So that means this is a percent decrease. My initial values, A out here, would be 2. And now for what is the percent, I'm just looking at how much off of 1 this is. And use a calculator. I get 0.08. And now to make that a percent, I'll multiply by 100 and get 8% decrease. Growth or decay, here's where I'm looking. Bigger than 1, that is growth. My initial value, I have nothing out there, which means there's a 1 implied. Because this is growth, this will be a percent increase. We want to figure out how much bigger than 1 is this. And now to make a decimal a percent, I'll move my decimal point 2 spots, and this is an increase of 20%. And same thing, these are really good questions. This is the majority of what you'll be looking at tomorrow in your assignment. Growth or decay, we look here. That's bigger than 1, so this is growth. My initial value is my B. Because it's growth, we have a percent increase. How much bigger than 1 is this? We'll go 1.02, subtract off 1, and I get 0.02. Turn that decimal into a percent, and I get 2%. Growth or decay, here's where I look. Smaller than 1, that's decay. Initial value is 1 implied. Because this decay will be percent decrease. How far off of 1 is this? And now I move my decimal 2 spots, fill in a 0. I'm decreasing by 20%. And the last one here. Look here. Smaller than 1, that's decay. Initial value, nothing there. Be 1. How far away from 1 is this? 0.05. Make this decimal into a percent for 5% decrease. Okay, great questions. That's what you'll be looking at tomorrow in your assignment on Thursday, is identifying just growth or decay, what's my initial value, and what is my percent increase or decrease. And the last thing one of the last things we haven't looked at is writing a model of decreasing. So the value of a car is $21,500. That's our initial value. It loses. Loses tells me this is decay. So our decay model, I'm going to write down here right away because we identify that it's decay. We can't forget here, we need to change this. We're going to write it down right away. I need to change a percent to a decimal. And write a function that represents the value in dollars after t years or x, it doesn't really matter. Now we'll just fill our things in. The value will be equal to the initial value times 1 minus our rate raised to the x. And let's simplify this a little bit, and then we're going to just plug in a value, a time. So we're going to say find the value. So this would be like part A. This was the model. And we're going to say find the value of the car after 6 years. So that means our x is becoming, because y is our value, x becomes 6. And we just type this in our calculator. Again, please type this in your calculator to make sure that you can do this, that you're able to type this in. 21,500 times 0.88 raised to the 6. And the value of that car after 6 years, don't forget a label, $9,984.68.